the function y is equal to kx satisfies the equation. Okay, so we have some big complicated differential equation for no values of k, exactly one value of k, and so on. Okay, so we need to figure out how many values of k for which the exponential function satisfies this ODE. So the way I think I'm going to do this, I think what's going to happen here is this ODE, once we substitute y is equal to kx in the ODE in this differential equation, all the derivatives are going to turn into, it's going to turn into an algebraic equation. Different derivatives are going to give us different powers of k. So if y is equal to e to the kx, when I substitute derivatives of y with respect to x, I'm going to get powers of k out. The exponential hopefully will cancel everywhere, and we'll just be left with an algebraic equation for k, which we can then solve for. So let's write out, I'm not going to write d squared by dx and so on. I'm just going to write this as y double prime plus y prime times y prime minus y is equal to y prime. Okay, so y double prime is k squared y prime is ky, y prime again, ky minus y, and this is equal to y times ky. So we can factor a y out from that, we can factor out a y from that, and we have two y's there which can be cancelled. So this becomes k squared plus k times k minus 1 is equal to k. All right. Now, how do we figure this out? Part of me wants to expand this and see if we can just read off the values of k that work. It doesn't say whether k is positive or negative or anything like that, but it's cubic, so there will definitely be an odd, unless there's there will be at least one solution. So there will be at least one, but at most three, right? So options A and E in the question are eliminated. Let me expand it and see if I can get a sense of what this function might look like. K cubed plus, k cubed minus k squared plus k squared minus k equals k. Oh, maybe this will be really easy to solve actually. So I have k cubed minus 2k is equal to 0. So this says k equals 0, or k is equal to, oh, no, 2 doesn't work. K squared minus 2 times k is equal to 0. Let me make sure I did the algebra correctly here. I went through that a little bit quick. K cubed minus k squared plus k squared minus k equals k. Those are gone. Yeah, so this is right. Okay, so k is equal to 0, root 2, or negative root 2. So the answer is D. There are exactly 3 values of k which work, and in fact, there they are. Yeah, I mean, the question's obviously set up so that we end up with a cubic equation we can solve. If we ended up with a more complicated cubic equation here, we might have still been able to figure it out based on, you know, where this as a function of k is increasing, decreasing, and so on. But by being able to solve it explicitly for k with all 3 values, there's not much more to be said here. Yeah, if I think of more to say, I'll write it in the description. Otherwise, thanks for watching.